Welcome to my channel. Today, in this session, let us discuss an example in time domain specification. So, the question is a unity feedback system is characterized by an open loop transfer function g of s is equal to k divided by s into s plus 10. The given is the open loop transfer function. For the open loop transfer function, determine the gain k. It is given in the g of s itself so that the system will have a damping ratio of 0.5. For this value of k, determine the settling time, peak overshoot and time to peak overshoot. We need to find out the three parameters, that is the settling time, peak overshoot, time to peak overshoot. Already we know that formulas to find out the settling time, peak overshoot and time to peak overshoot, right? And also for it is given for the unit step in. Okay, so let us write the given once again. G of s is equal to k divided by s into s plus 10. This is the open loop transfer function which is given. And given as the unit step input, I am considering the h of s is equal to 1. And the open loop transfer function is converted into the closed loop transfer function as C of s by R of s is equal to G of s by 1 plus G of s into H of s. So our G of s is K divided by S into S plus 10, 1 plus K divided by S into S plus 10, and I am also multiplying with the H of s. I have the H of s as equal to 1. So I am multiplying the h of s into 1. Anything into 1 will be the same value. So I am having the same value k divided by s into s plus 10. And after cross multiplying with this, I get the expression k divided by s into s plus 10 divided by s into s plus 10 plus k. So this will be divided by s into s plus 10. This will be equivalent to the expression as C of s and R of s is equal to k divided by s square plus 10s plus k. So this is the transfer function, and this is the closed loop transfer function which we obtain from the g of s expression. And g of s expression, our g of x expression here is k divided by s into s plus 10. And the unity feedback, since we have a unit step response, so we have considered the h of s is equal to 1. And for the provided transfer function, this is the characteristic equation, right? And this transfer function is equivalent to the standard form of the second order transfer function. The standard form of the second order transfer function is equivalent to omega n square by s square plus 2 zeta omega ns plus omega n square, right? So for the transfer function, the characteristic equation is s square plus 10s plus k, and the standard form transfer function is equivalent to s square plus the 2 zeta omega ns plus omega n square. So by comparing these two expressions, we can obtain the value of omega n square. What we have to find out the first, that means the unknown k value in the transfer function, right? So by comparing, I get the omega n square is equal to k, and while omega n square is equal to k, omega n is equal to root of k. And also I have the 2 zeta omega n value was 10 in the characteristic equation, right? I'm writing the 2 zeta omega n is equal to as 10. And by obtaining omega n is equal to 10, I can find out the omega n value, right? Which is equivalent to the k value. Okay, and already the zeta value is given us 0.5 in the problem itself. That means it is given us determine the gain k so that the system will have a damping ratio of 0.5. Consider this damping ratio as zeta. Zeta is equal to 0.5. So, by considering zeta is equal to 0.5, omega n is equal to 10 divided by 2 into 0.5, which is equal to 10. So, omega n is equal to 10, k is equal to 10, and omega n square will be equal to 100. This is the first unknown we have found out. We have found the unknown by the means of comparing the standard form of the second order equation, and by comparing the standard form of the equation and also with the help of the damping ratio which is given in the problem, we have come to know that omega n is equal to 10, which is equivalent to the k value, and omega n square is equal to 100. Once this is known, k is equal to 100, and we can find the other cases in the sense we can able to find the settling time, peak overshoot, time to peak overshoot. Since in all the three cases we want about the zeta and omega n, with the two cases we are supposed to find out the other three unknowns. Okay, so here our zeta is equal to 0.5, omega n square is equal to 100, and the formula to find out the settling time, Tn is equal to 4 divided by zeta omega n, which is equal to 0.8 seconds. By substituting that, that is 4 divided by, we know the zeta is equal to 0.5 into omega n is equal to 10. Okay, so by this we obtain the value as 0.8 second. And next is peak overshoot. For the peak overshoot we have the formula that e power minus pi zeta divided by root of 1 minus zeta square. So this is given by e power minus pi into 0.5 divided by root of 1 minus 0.5 the whole square, right? We obtain some value and multiply the value with 100. We get the peak overshoot value in percentages, 16.36 percentage, right? And next, once these all are known, we can also find out the time to peak overshoot. The time to peak overshoot TP, which is equal to pi divided by 10 root of 1 minus 0.5 the whole square. We obtain the value of 0.363 seconds. So we have to determine settling time, peak overshoot, time to peak overshoot with the help of the zeta and omega 1. Before that, we need to check whether the zeta and omega 1 an are known. If not, by comparing the standard expression, obtain the zeta and omega 1 values. Okay, and we have to note once again only in the case of this problem, we are obtaining the settling time. Since the settling time is not mentioned whether it has to settle at 2% or at 5%, if it is not mentioned, you just take this formula for obtaining the settling time. If it is mentioned, you just consider the 2% settling time and the 5% settling time. If it is if not mentioned, you just consider this formula. This is belong to the 2% of the settling time, right? And similarly, the peak overshoot. If you are asked towards the overshoot, you just stop here with this formula e power minus pi zeta by 2 root of 1 minus zeta square. If you are asked for the peak overshoot, you have to multiply with the base of 100 in this. Okay. So with this, I stop here and let me meet with the next video. If you have any queries, comment me in the comment section. If you like this video, like, share and